chapter 2 polynomial. First start with definition. Definition: polynomial is a function in variable x. P of x is equal to a raised to n, x raised to n, a raised to n minus 1, x raised to n minus 1 up to a0 x raised to 0, where n is whole number. Whole number starts with 0. So we have to take one example regarding polynomial. For example, p of x equal to x raised to 2 plus 2. N is equal to 2. Therefore, n is whole number. So, p of x is polynomial. Second example, p of x equal to x raised to minus 2 plus 3x. N is equal to minus 2 and n is equal to 1. Power is not a whole number, so given equation is not a polynomial. So now to take types of polynomial. Types of polynomial. First, based on number of terms. First one is monomial. It consists of one term. Second, binomial. It consists of two terms. For example, 2x. For example, 3x plus 5. And third one is trinomial. It consists of three terms. For example, 3x square plus 2x plus 7. These are types based on number of terms. First monomial, second binomial, third one is trinomial. Monomial consists of one term, binomial consists of two terms, and trinomial consists of three terms. Next, based on degree of terms. Degree of terms. First one is linear polynomial. Standard form: ax plus b, a is not equal to 0. In this case, highest degree is 1. Second, quadratic polynomial. Standard form: x square plus bx plus c, where a is not equal to 0. Highest degree 2. And third one is cubic polynomial. It has standard form: ax cube plus bx square plus cx plus d, where a is not equal to 0 and highest degree 3. So these are types of polynomial based on number of degree of terms. First one is linear polynomial. Standard form: ax plus b. Highest degree in linear polynomial is 1. Second one is quadratic polynomial. Standard form is x square plus bx plus c. A is not equal to 0 and highest degree in quadratic polynomial is 2. Third one is cubic polynomial, standard form x cube plus bx square plus cx plus d, highest degree is 3. Now next topic, zeros or root of the polynomial. Zeros or root of polynomial. In 9th standard we already studied root of polynomial. So take one example. P of x is equal to 2x plus 5. We have to find zeros of polynomial. So put P of x is equal to 0. So 0 is equal to 2x plus 5. 5 move right side to left side. 5 is equal to 2x. Therefore x is equal to minus 5 by 2. So zeros of polynomial P of x is minus 5 by 2. Zeros means nothing but at putting value of x minus 5 by 2, then value become 0. It's called zeros of root of the polynomial. In 10th standard we have to find zeros or root of the quadratic polynomial. So let's see quadratic polynomial. Zeros of quadratic polynomial. Standard form x square plus bx plus c, where a equal to coefficient of x square, b is equal to coefficient of x, c is equal to constant. Standard form of quadratic polynomial is x square plus bx plus c, where a is coefficient of x square, b is coefficient of x, c is constant term. Take one example. P of x is equal to x square plus 7x plus 10. Comparing with standard form, a is equal to 1, b is equal to 7, c is equal to 10. Now P of x is equal to 10. Write all possible factor of 10. 1, 10, 2, 5. When last term having positive sign, then addition of these two factors is equal to middle term, and both the factor have same sign which have to middle term. 1, 10. Sum is 11. Required 7. So first combination is not required. 2, 5, 7. Second is required. Both having plus sign. So P of x is equal to x square plus 2x plus 5x plus 10. Now x common, remaining x plus 2. From these two taken 5 common, x plus 2. X plus 2, x plus 2. These two brackets always same. X plus 2 common, x plus 5. So P of x is equal to x plus 2, x plus 5. We have to find zeros. So 0 is equal to x plus 2, x plus 5. Therefore x plus 2 is equal to 0, x plus 5 is equal to 0. X equal to minus 2, x equal to minus 5. So these are x equal to minus 2, x equal to minus 5 are zeros of given polynomial. Minus 2, minus 5. Answer is plus 10. C is equal to last term is plus 10, means your answer is correct. Now quadratic polynomial having maximum 2 zeros. One says alpha and second one is beta. Now next topic, relation between zeros of polynomial and coefficient. Relation between zeros of polynomial and coefficient of standard form of quadratic polynomial x square plus bx plus c. Now sum of zeros is equal to minus coefficient of x divided by coefficient of x square. Sum of zero is nothing but alpha plus beta minus b by a. First relation. Second, product of zeros is equal to constant term upon coefficient of x square, alpha into beta c upon a. So we got two relation between zeros and coefficient. Sum of zero is minus b by a and product of zeros alpha into beta is equal to c upon a. Next exercise is depend upon only these two formula. We have to equal alpha plus beta, alpha into beta. So let's take one example on that relationship. P of x is equal to x square minus 2x minus 8. Compare a equal to 1, b equal to minus 2, c equal to minus 8. A into c. 8. Write all possible factor of 8. 1 and 2, 4. When last term having negative sign, the difference between these two factors is equal to middle term, and larger factor have same sign which have to middle term and opposite sign to smaller factor. 8 minus 1, 7. We require minus 2. So this factor is not required. 2, 4. 4 minus 2, 2. So minus plus. So P of x is equal to x square minus 4x plus 2x minus 8. P of x is equal to x, x minus 4 plus 2 common, x minus 4. P of x is equal to x minus 4 bracket x plus 2. Now put P of x is equal to 0. So 0 is equal to x minus 4 x plus 2. 0 is equal to x minus 4 x plus 2. So x minus 4 is equal to 0, x plus 2 is equal to 0. 4 shift over, x is equal to 4, x is equal to minus 2. These are two zeros of this quadratic polynomial. Says alpha is equal to 4 and beta minus 2. Now we have to verify relation. First, alpha plus beta minus b by a. LHS, alpha plus beta. 4 minus 2, 2. Second, RHS, minus b upon a. Minus of minus 2 divided by 1. Minus minus plus, answer is 2. From equation 1 and 2, LHS is equal to RHS. So alpha plus beta minus b by a. Second relation, product of zeros is equal to c upon a. LHS, alpha into beta, 4 into minus 2 minus 8, equation 3, RHS, c upon a, minus 8 upon 1 is equal to minus 8, equation 4. From equation 3 and 4, right hand side is equal, So alpha beta is equal to C upon A. Hence verify. These are relationship between zeros and coefficient. First, finding zeros of polynomial by using splitting middle term or factorization method. Then x is equal to 4, x is equal to minus 2. One zero says alpha, second zero says beta. In relationship, alpha plus beta is equal to minus b by a. Alpha plus beta 2, minus b by a also 2. So alpha plus beta is equal to minus b by a. Similarly, we can do product of 0 is equal to C upon A. Next topic, when sum of zeros and products of zeros are given. When sum of zeros and product of zeros are given, we have to find quadratic polynomial. The formula is P of x is equal to x square minus sum of zeros into x plus product of zeros. So P of x is equal to x square minus alpha plus beta x plus alpha into beta. P of x is equal to k bracket x square minus alpha plus beta x plus alpha beta, where k is in integer. When zeros and products are given, then formula becomes P of x is equal to k bracket x square minus alpha plus beta x plus alpha beta. Sum of zeros 1 by 4, product of zeros minus 1. Now alpha plus beta 1 by 4, alpha into beta minus 1. These are given. We know that P of x is equal to x square minus alpha plus beta x plus alpha beta. Put value of alpha plus beta and alpha beta in this equation. So equation become P of x is equal to x square minus 1 by 4x minus 1. So P of x is equal to x square minus x by 4 minus 1. Multiply by 4. So P of x is equal to 4x square minus x minus 4. This is required quadratic polynomial where sum of zeros and product of zeros are given. Second example, similar. Sum of zeros 4, product of zeros is 1. Now alpha plus beta is equal to 4, alpha into beta 1. So P of x is equal to x square minus alpha plus beta x plus alpha into beta. Put value of alpha plus beta, alpha into beta in this equation. So P of x is equal to x square minus 4x plus 1. This is required quadratic polynomial. Now next topic, division algorithm for polynomials. Dividend is equal to divisor into quotient plus remainder. P of x is equal to g of x into q of x plus r of x. When remainder is 0, then g of x is a factor of p of x. Second, when remainder is not equal to 0, then g of x is not a factor of When remainder is 0, then g of x is always factor of p of x. If remainder is not equal to 0, then p of x, g of x is not a factor of p of x. Now let's solve the example. P of x is equal to x cube minus 3x square plus 5x minus 3. G of x is equal to x square minus 2. Okay. Find quotient and remainder. X cube minus 3x square plus 5x minus 3. P of x is divided by g of x means x square minus 2. X square, x cube. X square multiplied by x, we get x cube minus 2x. Minus sign change, minus plus. Cancel. Minus 3x square plus 7x minus 3. So minus 3 into x square minus 3x square minus 3 minus 2 plus 6 minus plus minus. So 7x minus 9. Remainder, and this is quotient. Therefore, quotient q of x is equal to x minus 3. Remainder rx is equal to 7x minus 9. So remainder is not equal to 0. R of x is not equal to 0. Therefore, x square minus 2 is not a factor of x cube minus 3x square plus 5x minus 3. P of x is equal to 2x square plus 3x plus 1. G of x, x plus 2. 2x square plus 3x plus 1, x plus 2. We want 2x square, here is x. So multiply by 2x, 2x into x, 2x square, 2x into 2 plus 4x, minus, minus, minus. 2x square, cancel, opposite side. 3x minus 4x, minus x plus 1, minus 1, minus 1 into x, minus 1 into plus 2, minus 2, minus sign change, plus, x cancel. So remainder is 3. Quotient is 2x minus 1. P of x is equal to 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12, and g of x t square minus 3, 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12, g of x. Now let's p of x ascending order, t raised to 4 plus 3t cube minus 2t square minus 9t minus 12, g of x t square minus t square, we want 2t raised to 4, so multiply by 2t square, 2t square into t square, 2t raised to 4, 3 2s are 6, so minus 6t raised to 4, minus plus 2t raised to 4 minus 2t raised to 4, cancel. 3t cube as it is, minus 2 plus 6 plus 4t square minus 9t. Here we want 3t cube plus 3t. 3t into t square, 3t square, 3t into minus 90, minus plus, cancel, 4t square minus 12, 4t square plus 4 into t square, 4t square, 4 into minus 3, minus 12, minus plus, cancel. So remainder is 0. So remainder, since remainder is 0, therefore t square minus 3 is a factor of 2t raised to 4 plus 3t cube minus 2t square minus 90 minus 12. After long division, when remainder is 0, then we say that t square minus 3 is a factor of given polynomial. If remainder is not equal to 0, then we say that given g of x is not a factor of p of x. Now next sum. Find all the zeros of 2x raised to 4 minus 3x cube minus 3x cube minus 3x square plus 6x minus 2 if 2 of its zeros are root 2 and minus root 2. P of x is equal to 2x raised to 4 minus 3x cube minus 3x square plus 6x root 2 and minus root 2 are zeros of given polynomial. So alpha is equal to 2, beta equal to minus root 2. So g of x is equal to x square minus alpha plus beta x plus alpha into beta. G of x, zeros means nothing but it is a factor of this polynomial. So x square minus root 2 into x plus root 2 into minus root 2. Cancel. So x square minus 2. So g of x is a factor of p of x. So divide p of x by g of x. Two x raised to 4 minus 3x cube minus 3x square plus 6x minus 2 divided by x square minus 2. X square, here we want 2x raised to 4, so multiply by 2x square. 2x square into x square, 2x raised to 4. 2x square into minus 2, so minus 4x square. Minus plus, cancel, minus 3x cube plus x square plus 6x. x square यहाँ पे है minus 3x cube, so multiply by minus 3x. Minus 3x into x square minus 3x cube minus 3x into minus 2 plus 6x minus plus minus cancel, x square minus 2 multiply by 1 into x square 1 into minus 2 minus plus cancel 0. Now q of x is equal to 2x square minus 3x plus 1. Factorize q of x is equal to 2x square minus 2x minus x plus 1. 2 common. X minus 2 minus 1 common. X minus 1. So 2x minus 1. X minus 1. So 2x minus 1 is equal to 0. So 2x is equal to 1, x equal to 1 by 2, and x minus 1 is equal to 0. So x equal to 1. So remaining zeros are 1 by 2 and 1.